Hello students, welcome back. Let us take a look at a small exercise before we quickly proceed with the topics that we will be covering in this chapter, just to understand whether you got the concept cleared. Okay. So, solved example on page 3, you have to state whether the following statements are true or false and give reasons for your answers. So, the first one, every whole number is a natural number. So, you have to state whether this statement is true or false. What do you think? Let's take a look. Whole numbers are 0, 1, 2 up to infinity, whereas natural numbers start from 1, 2 and so on. Therefore, there is an extra 0 in whole numbers, right? Whereas it does not exist for natural numbers. So, this statement is false because 0 is a whole number and not a natural number. I have just written W for whole number and N for natural number because W is used to denote whole numbers and N is used to denote natural numbers. Okay. Second one, every integer is a rational number. So, remember our diagram, we had this was irrational numbers, this was rational numbers, this was a real numbers, right? Within rational numbers, we had integers, then whole numbers, then natural numbers. So, you see that integers are represented by Z. So, you see that the integers are a part of rational numbers, right? So, this statement is true and you will have to give an example. For example, minus 1 or let us say minus 2 is an integer and it can be expressed as minus 2 upon 1, right, where 1 is not equal to 0, right, which is the definition of your rational numbers, where rational numbers can be represented as P upon Q, where Q is not equal to 0, correct. So, this statement is true. Now, the third one, every rational number is an integer. So, every rational number is an integer. We had rational numbers and within that was integers, right. So, not all integers are rational numbers, but not all rational numbers are integers. So, this statement is false. And let us give an example. 2 upon 3 is a rational number, but not an integer, right. So, every whole number is a rational number, no, it is false. Every integer is a rational number, true, and every rational number is an integer, false. Okay, so, we have completed solved example 1 on page 3. Now, let us quickly proceed with the topics to be covered. Before that, I will just erase the board because we will be needing it. So, the topics that we will be covering in this chapter after the definition of the number system and the different numbers that we have are how to find rational numbers between two given rational numbers. So, if you have been given two rational numbers, so remember when we said that there are infinite number of rational numbers. So, there exists infinite number of rational numbers between two rational numbers and we will have to find a few rational numbers between two given rational numbers, right. Then points to remember for real numbers, how to locate irrational numbers on a number line. For example, how to locate root 2 or root 3 on a number line. Real numbers and their decimal expansions. detailed difference between rational and irrational numbers. We have just seen the definitions of rational and irrational numbers, the basic difference, but we will take a look at a more detailed description by solving examples in this section. Then you have special properties of rational and irrational numbers, representing real numbers on a number line. Just like we will learn how to represent irrational numbers on a number line, we will see how to represent real numbers on a number line. Then operations on real numbers, of course there are numbers, so it is by default it is understood that there will be operations on that, so we will be taking a look at those operations. Then laws of exponents for real numbers. Alright, now let us start with the first section, find rational numbers between two given rational numbers. Okay, so my first topic, between two given rational numbers. Okay, Q for rational. So I am going to say let x and y be two rational numbers. Okay, with y greater than x. So now we need to find rational numbers between two rational numbers y and x. Okay, such that y is greater than x, or you could even take x is greater than y, that's no problem. So we've defined our two rational numbers and we will be finding other rational numbers between them. Now first of all, there are two ways to go about this. Also I have discovered a new method recently to overcome those two other methods, so I'll explain all three of them to you. So let's take a look at the ones that have been given in your textbooks. Okay, so the first step is, or method 1, so to find two given rational numbers between two given rational numbers, the formula is x plus y upon 2. Okay, so if suppose you have x and y, you are going to add x and y by 2, then whatever output you get, you are going to add another term to it and divide it by 2, and then you keep doing that successively to find the rational numbers. The other method is method 2, also known as one-step method to find rational numbers. Okay, we will take a look at the examples later how to solve this, but just let's understand the formulas first. Okay, so one-step method. Now this is nothing but let D be the difference. Suppose you need to find n natural numbers. Suppose n rational numbers. Okay, you will first find a difference D. Okay, D is a difference. The formula for this is y minus x upon n plus 1. Okay, so if suppose you need to find 6 natural numbers, you are going to say 6 plus 1 and y minus x, because y is greater than x. If you take x greater than y, then it will be x minus y. Okay, now to find these n rational numbers, the formula is n rational numbers are x plus d, x plus 2d, x plus 3d up to x plus n d. Okay, so if you need to find 6 rational numbers, you will keep adding. Suppose this is 1d, 2d, 3d, 4d, 5d until x plus 6d, right? So these are the two traditional methods that have been given to you. We will see the other method that I just discussed with you while I am doing one of the solved examples. So please take a look at this before I proceed with the solved example. So let me erase the board and then I will write the question and explain you. So this is solved example of your textbooks, page 4. Sum number 2. Find 5 rational numbers between 1 and 2. Okay. So you need to find 5 rational numbers between 1 and 2. We are going to follow the method 1 and 2 that we discussed in the just previously, and then I will show you another method as well. So solution, step 1. So let's say let x be equal to 1 and y be equal to 2. According to method 1, you have x plus y upon 2, right? These are successfully you are going to keep doing this in order to find the rational numbers. So the first one will be 1 plus 2 upon 2, which is 3 upon 2, right? Then I am going to take 1, I will say x be equal to 1 and y be equal to 3 upon 2, right? Then again I have x plus y upon 2 is equal to 1 plus 3 upon 2 upon 2, right? This is equal to 2 plus 3 upon 2 upon 2. Why 2 plus 3? I am taking the LCM over here. This is nothing but 1 upon 1. Now the LCM of 1 and 2 is 2. So I have multiplied this by 2 and the denominators become the same for this particular numerator. So 2 plus 3 upon 2, this is nothing but 5 upon 4, right? So I have found my first rational number. Second, I need to find 3 more. Again I am going to take, this was 1, this is 2. Now again I am going to take x is equal to, I will take my x as 2 and y be equal to 3 upon 2. So you see I took 1 and then 3 upon 2, now I am taking 2 and 3 upon 2. You can take any of these, 1 and 5 upon 4, 3 upon 2 and 5 upon 4. I am just taking the simple ones. Okay. So x plus y upon 2 is equal to 2 plus 3 upon 2 upon 2. Again taking the LCM of this numerator, what do I get? 4 plus 3 upon 2 upon 2, right, which is 7 upon 4, correct? Again I am going to take x is equal to 3 upon 2 and y is equal to 5 upon 4. Right? So x plus y upon 2 is equal to 3 upon 2 plus 5 upon 4 upon 2. Now the LCM of this numerator is 4. So 3 2s are 6 plus 5 upon 4 upon 2, right? So this is going to be 11 upon 4 into 2. How 4 into 2? This denominator is coming down over here. So it's getting multiplied with 2. So this would be 11 upon 8, right? So 1, 2, 3, 4. Okay. Now I'm going to take x is equal to, let's say 5 upon 4 and y is equal to 7 upon 4, right? So x plus y upon 2 is equal to 5 upon 4 plus 7 upon 4 upon 2. right? They have a common denominator, this particular numerator over here, right? So this would be 5 plus 7 upon 4 into 2, right? I took the 4 down. So this is going to be 5 plus 7 is 12 upon 8. Okay. So I have found 5 rational numbers between 1 and 2. Now if you can just quickly, verify, see if I divide 3 by 2, it will go with 1, it won't go with more than 2, right? 2 point something, 2 ones are 2, 2 1 point something. Similarly over here, 4 ones are 4 point something, 4 ones are 4 point something, 8 ones are 8 point something, and 8 ones are 8 point something. Nothing is going more than 2, right? So the quotient is not going, the quotient is fluctuating between 1 and 2 and it's not more than 2. So these are my 5 rational numbers. They would be infinite. You can keep going with these calculations and you will find infinite number of rational numbers between 1 and 2. But since we were asked to find only 5 of them, I have found these 5 using method 1. So I will write it down somewhere. Have you just taken a look at this? You just need to write the answer. The 5 rational numbers between 1 and 2 are 3 upon 2, 5 upon 4, 7 upon 4, 11 upon 8 and 12 upon 8, right? So I have found 5 rational numbers between 1 and 2 using method 1. Let's just erase the board and do it by using the second method. That was the one-step method. So in method 2, I will say let x be equal to 1 and y be equal to 2. So what you have to do in method 2 is you have to first find a difference d such that d is equal to y minus x upon n plus 1. Why y minus x? Here y is greater than x, right? Therefore y minus x. If you would have written x as 2 and y as 1, then it would be x minus y upon n plus 1. So now what is n plus 1? n is nothing but 5, because we have to find 5 rational numbers between 1 and 2. So your n plus 1 is going to be 5 plus 1. So this is nothing but 2 minus 1 upon 5 plus 1, which is 1 upon 6, right? So now the 5 rational numbers can be denoted as the 5 rational numbers between 1 and 2 are x plus d, x plus 2d, x plus 3d, x plus 4d and x plus 5d, right? For 1, 2, 3, 4 and 5. So 5 rational numbers that we need to find. Now this is going to be very simple. This is nothing but 1 plus 1 upon 6, which is 6 plus 1 upon 6, which is 7 upon 6, right? This is going to be 1 plus 2 into 1 upon 6. So this is 2 into 1 upon 6, 2 ones are 2, 2 threes are 6. So 3 plus 1 upon 3, which is equal to 4 upon 3. Got it? Then you have 1 plus 3 into 1 upon 6. 3 ones are 3, 3 twos are 6. So I get 2 plus 1 upon 2, which is 3 upon 2. Correct? Then I have 1 plus 4 into 1 upon 6. So 2 twos are 4, 2 threes are 6. So what do I get? 3 plus 2 upon 3, which is 5 upon 3. Correct? And finally I have 1 plus 5 into 1 upon 6, which is 6 plus 5 upon 6, which is 11 upon 6. Now you can verify that all these numbers, when you divide, they will lie between 1 and 2. For example, if you divide 7 by 6, you get 1 point something. 4 by 3, again the quotient will be 1 point something. For 3 upon 2, the quotient again is 1 point something. Similarly for 5 upon 3 and 11 upon 6. Therefore, all these numbers are lying between 1 and 2. Therefore, I will say the 5 rational numbers between 1 and 2 are 7 upon 6, 4 upon 3, 3 upon 2, 5 upon 3 and 11 upon 6. This is also my answer. Right? So, I have found 5 rational numbers between 1 and 2 by using the second method. Now, remember when I told you that I have discovered recently a new method for finding these rational numbers in a much more simple and quick way. Let's find that out, okay? We learned that there are infinitely many rational numbers between infinitely many rational numbers. So, even between any two given numbers, there would be infinitely many rational numbers. So, let's say I have 1 and 2, correct? 1 can be written as 1 upon 1 and 2 also can be written as 2 upon 1. Agreed? Now, let's say if I multiply the numerator and denominator by 10. What do I get? I get 10 upon 10 and 20 upon 10, right? So, my other rational, what I am going to do is I am just going to increase the count by 1, okay, in the numerator. So, I have 11 upon 10, 12 upon 10, 13 upon 10, 14 upon 10, 19 upon 10, right? So, we know that this is 1, right? 11 upon 10 is nothing but 1.1, 12 upon 10 is 1.2, then this is 1.3, 1.4, 1.9 and 2, right? So, isn't this a very simple method to find the rational numbers? Now, let's say instead of 10 we had taken 100. So, we would have had 100 upon 100 and 200 upon 100. Now, just imagine the number of rational numbers that we would have in between. 101 upon 100, 102 upon 100 and the list would go on, right, until 200 upon 100. So, you can see that there exists infinitely many rational numbers between any two given rational numbers, right? Now, this is nothing but 1.01, 1.02, 1.03 and so on until you get 2. So, we have learned how to find rational numbers between two given rational numbers, okay? Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.